how we face a problem in competitive programming. So, like everyone, every competitive programmer, what do we do? What we do is we start by reading problem, then we say, I solve the problem. But solve is a very ambiguous word, right? By solve, we mean that I discovered the idea to solve this problem. And what does idea mean? It's like, I know that I should convert the problem into a graph problem. Then, like, maybe I should use matching algorithm. Then I need to print certificate, and that's it. Like, idea is usually like single line or at most 2 lines, right? But okay, let's see what happens. So we have idea, and here is AC, like getting AC. Here is another step, which is submit. We do this step, but we never reach this. Why? Because we go to this step, which is debug, and we go back, right? There is a significant problem here, which makes us keep going in this cycle instead of going into this direct path. I want to name the most important reason of falling into this cycle instead of going into this path today. So actually what we do, if we, let's find some random normal engineer, like an engineer who builds the buildings, like how do you call him? Like engineer, civil engineer, right? So go meet a civil engineer and ask him, this is how we solve problems in computer programming. Like, you don't need to tell him the problems, you need to show him how you solve them. What is your typical process? Like, they solve problems too, right? Their problems are different, but this is something in common, which is very important, which is what we do is somehow engineering too, and what he does is say. So there are some things in common, and so the solution to make solutions should be somehow in common. Not solutions, like they don't use segment trees and network flows and all, right? But the solution to make solutions is somehow similar. Let's come with other like example. Like, consider people who like learn philosophy, okay, and people who do literature. They solve very different problems, but the solution to get solution in those fields are almost equal. Like, it's like going into some feeling and find some solution that will not work for us, right? This is so far from what we do. But we have a lot of commons with engineers who do like software engineering for sure, even like civil engineering. I want to focus on civil engineering actually, while I know nothing of them, but what I want to use is very common. So let's meet some civil engineer. Do you know Mila Tower in Iran? We have a very tall tower in Tehran, which when it was built, it was the 5th highest tower in the world, but now it's like, I think it's 20th. So let's meet some civil engineer and say, I want to build a very tall tower, let's say Mila Tower, which has something around 500 meters like height. So let's meet him and tell him I want to do that, and yeah, give him $1 million, a few $1 million if it's enough, and let's see what he does to use his thinking style, solution of making solutions, to use in computer programming. Okay, we want to learn from a civil engineer how to solve problems in computer programming. I'm sure that will be useful. So let's see what happens if he does exact same as we are doing in computer programming. So Then we tell him the problem. Problem is building Milo Tower. So consider that Milo Tower is not there because it's just copy pasting. Like it's not a problem. Like it's copy pasting. Copy pasting can be a problem. So what we do is, okay, I have idea. Idea is making a tower like this much height, and like let's say it needs some elevator, and let's say some antenna on it. And let's say maybe we need to have a restaurant on the top. It's nice, right? It has some restaurant actually on the top, and yeah, maybe some like hotel and all. And then he says, okay, and he comes with some, let's say 100 workers and 100 machines and all, and they start building. What we do in computer programming is this, like going from idea right to the construction. Like he has the idea like on the paper some night, and tomorrow morning he comes with 100 workers and constructing machines, and let's start. Do you think that even he can build some like 2 floors of it? It's not possible. Like it's like funny for us, right? But why it's not funny for you that you do this? You have idea and you go directly. We have some other step here, which is coding. Actually, you don't submit empty code, right? You should code before you submit. So to make them consistent, let's write code instead of submit. You code and submit. Like it's like idea, construction, delivery, and what you deliver in the civil, if you civil engineers, was $1 billion wasted. Like we need some debug, but fortunately, the thing is, debug doesn't have huge costs in competitive programming, right? It just has some penalty, which is 20 minutes of penalty and wasting keyboard time of other teammates and ruining the result of the contest. That's why we don't care that much as a civil engineer. Take care about having good solution to make solutions. So let's see what really we are missing. Like the issue here, a hint is the issue here is jumping directly from idea to code, from idea to starting the real construction. That's the issue. So it seems that we are missing something here. Like very easily use pattern of what civil engineer do. What do you do? Like plan. Yeah, so he goes like takes some maybe year on making a very good plan of not even every single floor, but also the construction steps. Like first we need this number of workers, this number of working machines, and then digging the ground for like 100 meters and so on and so on and so on. Yes, but we don't plan, right? Did you ever plan for coding? Like you plan, meaning that I plan to participate in code versus contest, but you don't plan how I'm gonna implement this idea. Like to face it in a different manner, idea is the highest thing in abstraction manner. Like if we have some, let's say, axis of abstraction, the extreme thing here is idea. Idea is very abstract. Like we can have different interpretation of ideas. It can even have some bugs, like not bugs, even mistakes in it, right? Idea can be incorrect at all, like because it's very abstract. We don't know all the details of it, right? But let this be 0, like the origin of this axis. What is the least thing in abstraction? So idea is a kind of solution. So what kind of solution that has 0 abstraction? The implementation. So code is here. So let's say I know that we can't show infinity in axis, but in our limited board. But let's say ideas abstraction is infinite, like it's a lot, let's say. But code's abstraction is 0. And we jump directly from here to here, which is impossible. Actually, it's not impossible, but it leads to this cycle. Like we submit and we go debugging. Or even we don't submit, like it's getting wrong answer on some sample test case. Or even while we are implementing, we understand that our idea is incorrect. Like a lot of waste, right? And all of these things are happening because of this. Because we are trying to reducing the abstraction at once from infinity to 0 while we are typing code. Like the hardest time to think is when you are typing. It's so I always say this sentence, this quote, that when laptop is open, mind is closed. So close your laptop to let your mind open. So you can think while you are typing, while you are coding, you can think. Close it, think on paper. So this is a tool for typing, for coding. This is not a tool for thinking. Tool for thinking is this. So you think on this, you code in this. Like, don't misuse things. Okay. So how we should solve this issue? Like, what we should do here?
Big copyrights, water blocks, and think about how these work daily on different attack. So you should keep in that idea. Implementation. We got to sort of and see okay how we do it for actually.
Can you describe what you said in one word? Plan or a strategy, they are good. But what I call it is fixing. So by fixing, it's like idea is something like a code. Like you can't see it, you can't fix it, you can't implement it. It's a very like not manageable. You write it down, you push it down on the paper, like now it's on the paper, and now you can push what you have on the paper to the code. Like pushing that thing, that super abstract thing directly into code is impossible. But you can have it first on paper and then on your code. Like let's say idea goes on paper like in 5 lines, and finally you convert it into a code which has like 100 lines. So did you see that you start coding some problem with a good confidence, and while you are coding you stop somewhere and you start thinking. You do this because you didn't fix your idea. If your idea was fixed, you never stop. Like why someone stops construction of Milad Tower at the middle of the project? It never happens, right? It never happens. If you run out of funds, yes, but we never run out of funds because electricity is there. We don't. Our funds is just having electricity to continue coding. So I remember that we had a teacher like something like 12 years ago. He was like, if he see you thinking for more than 10 seconds while you are typing code, like you're starting coding, like implementing your solution, and suddenly you stopped for more than 10 seconds, he came, Control A, then backspace, then Control S, and then Alt and F4. Alt and F4 to make sure you don't use Control Z. Okay, and Control S to make sure that the empty file is safe. Why? Because it should be a practice that you should do all the thinking needed before you start coding, not during you are coding, because it's waste of time, waste of keyboard. Like keyboard is very valuable during a team contest, right? It's you have mind for 15 hours, but you have keyboard for 5 hours. So it's a very limited supply that you should protect it really. Okay? So you came here, you started coding, you are using this precious supply, and you go thinking suddenly, like for 10 minutes. What a waste. So you should do that on paper before you do it. So let's learn what should we do in fixing, which is very important. So fixing should be enough material to make the code. Like, consider like this. Somehow fixing is something that if you give it to a new guy on code forces, he should be able to implement the solution using what you wrote on paper plus searching on Google. Like, for example, you can write like make a segment tree on array A with plus operation and max. Okay, a new guy on code forces may not know segment tree, that's okay. But he can just search segment tree with these operations and he'll see an implementation and copy paste and do what you said, right? So fixing is you pick some piece of paper, you start writing important things you need while coding. It's not pseudocode. Pseudocode is writing pseudocode on paper is waste of time. In competitive programming, we really need to be fast, right? So pseudocode is not what we need, except for very rare cases that someone is coding, you don't have anything else to do, you just need one AC and you start coding on paper and you just go type it as fast as possible when keyboard is free. But we are talking about fixing, we are not talking about pseudocode. So one thing you need to write is the functions you are gonna implement in your code, and also objects, and also important variables. They are important. Like if you have some temporarily variable, no need to define. If you have some variable that is, you keep it as is in the input, like array A is given in the input, no need to write it here because you know its name, like n, you don't need to write it here. But for example, you are implementing stack like DSU on tree, and you have a very important variable which is your, like, let's say stack or your bag. You need to define, you need to write its name right here. Why? To have this in your mind, and while you are thinking, you say that instead of saying I will push this value into that variable, you say I will push this number into variable named stack. I will push it into stack, or I will push it into bag 1. Like let's say you have bag 1 and bag 2. You will say I will push it to bag 1 instead of I will push it to that bag and this bag, and you'll get mixed of them, that which one was this bag and which one was that bag. Okay. Something else to cover during fixing is DP formulas. So when you are doing DP, you need to carefully cover. Yeah.
If they're writing DP formulas, is that not just writing a pseudocode at that point for DP? Like, what is the difference between fixing and pseudocode for DP codes?
So if the solution is just some DP, what you are gonna write on paper is very similar to what you are gonna implement. But there are very few number of problems that, if that's the case, the problem is gonna have just 10 lines of code. It's okay to have it on the paper and the computer, that's okay. But this is something that's necessary. Like you should start with DP bases. Like what are my bases? Like for example, zeros and 0i and I0. I should define all of them. I should set them to blah blah. And then what is my DP transitions? Maybe there are some condition, like for odd I do something, for even I do something else. You should define all of them. Are you going to do DP using just force from bottom, using bottom up solution, or vice versa? You are going to do it using a function and memoizing using a top bottom option. You need to write everything like this here. And something else that is very important is off by ones. So do you know what is off by one? Off by one is like you have some if like this. You don't know that this should be like this or this or this or this, and maybe this So these are different kinds of Python that we face a lot in competitive programming, right? And what we do, we write like this: running sample test case, it doesn't work. Change it to this. Running a sample test case, it didn't work. Changing to this. Running the sample test case, it worked. Submitting, getting wrong answer because the correct was using this in combination with +1 in here. Or maybe the bug was something else. Like we are wasting time on this. This was correct. And it's like -1 times -1 equals to 1, right? You had some bug somewhere else. You covered it with another mistake here, and you did and it passed the sample test cases, and you submit and got wrong answer. And now you are lost because you think that issue is here, and you missed the big bug that is somewhere else. But if you fix the code before, you know that this is 100% correct because I have this on paper. And after getting wrong answer on some sample test case, you would go finding for real bug, which is hidden somewhere else. I remember one amazing night that I went to one of our gold medalists' house to help him get AC for his homeworks. Like after people get gold in Olympiad of Informatics in high school, they have a very long camp of like 5-6 months, and they have a lot of homeworks to do. They have a lot of exams to do, and so on, to finally pick the best 4 out of 8, which will be the representatives of like Iran in International Olympiad of Informatics. So I had a friend and the student, something between them, that he won gold medal, and he was struggling with doing homeworks and all. And yeah, we were friends. So I went to his house, starting getting AC as many as possible homeworks before the deadline, which was like early morning. I don't remember, but a very early morning. So we were solving problems one by one, and it was getting late and late and late. Like my usual sleeping time is 10:30 p.m. Like I sleep very early. And yeah, it was going to like 1 a.m., 2 a.m., like around 3 a.m. I was so sleepy that I couldn't keep my eyes open. And we submitted some code for the last problem we wanted to solve, and it was getting wrong answer. And there were 3 ifs in different parts of his code. Like let's say if x less than y, if a is less than b, if v is less than u. And we were 100% sure that the issue is inside one of these things, and one of these things should be greater, not less. And guess what he did? He defined 3 Boolean variables b1, b2, b3, set all to 0, XOR this equation, this expression with b1, this with b2, this with b3, and then submitted 8 different codes, and then we slept. So this is very bad practice, right? If we actually fixing in that situation was not possible because it was very late night. But if we had fixed this code before going to implementation, we even didn't receive the first wrong answer, right? We could know that this should be like greater, this should be less, this should be less, that's it. Okay? So random debugging is something computer programmers always do, and which is wrong. And why they do this? They do this because they did another mistake before that it led them to this situation that they need to make another mistake. Like you first do a mistake, then you miss this crucial part that is fixing. Then now you come to a new state that the only choice you have is making another mistake, which is random debugging. It happens a lot in our life. We make a mistake that it moves us to a new state, that in this new state, you have no other choice than making another mistake. Like a lot of times this is like this. So fixing is a crucial, what I wanted to cover was fixing is a very crucial part of problem solving. You can start with what I wrote here. like functions, objects, like off-by ones, like DP formulas, important variables, and all. And you will understand what else is necessary. Like, for example, if you are converting a problem to graph, it's very crucial that you need to define how you are going to give IDs to your vertices. Like, you are maybe merging a few things together to make a very huge graph, and you need to know, what do I name this, what do I name this, what do I name this. Like, for example, I will multiply everything by 3 and then plus v. Like, I will become like I times n plus, let's say, something like max n, and something like this. You need to fix everything like this before you start coding. And one thing before we leave, um, something that helps you, having a better fixing is a fixed mind. So if you have a structural thinking, not just thinking as it goes, no, a structural thinking, like how a software engineer faces a problem. He faces a problem with first detecting the objects and functions, not trying to just come with some working solution. No. So many times I see computer programming is not defining objects and functions at all, just going implementing something, that's it. So this is not good. It will ruin your mind. Like, in long term, it will ruin your mind. And another dangerous thing is, you need a lot of time to become a good software engineer then. So most of you are gonna become software engineer after a while, right? Like, you can hear very opposite comments from people who hire computer programmers, like not like elementary computer programmers who really go for masters, international masters, grandmasters of computer programming. They hire them. You can hear two very opposite comments. Some say they are very good problem solvers and all, and some say they just ruin our codes in our company. So, why this happens? Dirty code comes from dirty mind. So first, you need to clean and make your mind neat and fixed to produce neat and clean code. So it's important. Try to take care, try to pay attention to not just getting AC, and instead write a clean AC code, write a neat AC code, which will help you. Like, in maybe at the start it will like take some time, but after a while you'll see that, wow, it's even helping me in competitive programming. I'm solving problems easier. I'm getting ACs faster with less debug time, right? So that's it about structural thinking.